So here we are going to see the problem related to beam column. Okay, now whatever we have seen before. Okay, that is with respect to the central point load. Now the given data are determine the maximum stress. That is, they are asking for sigma max. So we have to calculate the sigma max induced in a cylindrical steel strut of length. So they have given that the length L, length of column L is equal to 1.2 meter, which is nothing but 1200 mm. Okay, and the diameter of column. So column dia is equal to 30 mm. Okay, next this is nothing but L, this is D. I'm going to denote, and the strut is hinged at both ends. Okay, so pinned at both the ends, pinned at both the ends, pinned at both the ends, and subjected to an axial thrust. So this is nothing but axial compression force. So axial compression force or compression load P is equal to 20 kilonewton. Next, attendance, the transverse load. Okay, so W is denoted as transverse load 1.8 kilonewton at the center. Okay, at the center, acting at the center. Okay, now, and they have given that E is equal to 208 giganewton per meter square. So which is nothing but E is equal to 208 into 10 cube Newton per mm square. So these are all the given datas. Okay. Now we should move on to the stress. That is formula. Okay. Sigma max is equal to solution. Okay. Solution part. So stress sigma max is equal to, we know that direct stress plus bending stress. So direct stress sigma D is equal to P by A. Okay. But bending stress, the formula is W by 2 into root under EI by P into tan L by 2 into root under P by EI into YC by AK square. Okay, so now we have to calculate these things. Okay, M max and these values and all we have to calculate. Okay, so in other hand we are going to denote that M max into Y divided by I. Okay, so I value we have to calculate. So first of all, area. So they have mentioned that cylindrical section. So pi by 4 into d square. Okay. So just a minute, I will take the calculator. So it is 706.86 mm square. Okay, area. Then I value, that is moment of inertia. I is equal to pi by 64 into d power 4. Okay. So the value becomes 39.76 into 10 to the power 3 mm power 4. So this is the value of I. Okay. So from this we can calculate sigma D value. So that is P by A. So P value they have given us 20 kilonewton. So 20 into 10 cube newton divided by area becomes 706.86. So 28.29 Newton per mm square. So this is the value of sigma d. So next we should move on to the sigma b value. Okay. So in that first m max. So w by 2 into root under ei by p into tan L by 2 into root under P by E. So this is the value of M max. Okay. Uh, so Young's model Z value they have given. Okay. So let us substitute these values. Okay. W is 1.8 kilonewton. So 1.8 into 10 cube divided by 2 into root under. E value is 208 into 10 cube into I value is 39.76 into 10 cube. 39.76 into 10 cube divided by P. Load P value is 20 kilonewton. 20 into 10 cube. Okay, into tan L by 2. So L is 1200, correct? Divided by 2 into P by E. So P is 20 into 10 cube. E value is 208 into 10 to the power 3 into I value is 39.76 into 10 cube. Okay. So these values we have to substitute. So here this term becomes 900 newtons, then this term becomes 643.04, this term becomes tan 0.933 radians. So the radians I am going to convert into degrees. So in order to convert that, I am going to give 180 degree by pi, so that it becomes 53.46 degree. So if I am going to substitute these values into here, I am getting the m max value as 780.89 780.89 into 10 cube newton mm. Okay. Next I have to substitute remaining values. Okay. Which is nothing but m max I can have, that is I value, those things I can have. Okay, so that I'm going to substitute. So sigma b is equal to m max into y c by I. Okay, so here yc is nothing but our given section is circular section, it is 30 mm. Okay, so from the centroid what is the distance? That is my yc, that is equal to y. So how much it is? 15 mm. Okay, so y is equal to 15 mm. So I can substitute these values into here. So 780.89 into 10 cube into 15 mm divided by I value. So 39.76 into 10 cube. So by substituting these values, I can get the value of bending stress value, that is 294.6 Newton per mm square. Therefore, the maximum stress sigma max is equal to the addition of direct stress plus bending stress. So direct stress value is 28.29 plus bending stress value is 294.60. So the total stress value becomes 322.89 Newton per mm square. So this is the value of bending stress. Sorry, maximum stress. Have you got it?